To another edition with NetGru. Today we have another special guest, Trevor Mako. We're going to talk about Meraki MV cameras, machine learning, image detection with Meraki MV cameras. So it's going to be a really fun session. Thanks everyone for joining. Trevor, would you like to say a couple of words about yourself, introduce yourself to folks?
Yeah, absolutely. So, hey, everyone. Really good to be here. Adrian, thanks for having me. My name is Trevor. I'm a programmability specialist here at Cisco. I'm part of a team called DevNet, which if you caught one of the sessions a few weeks back with my colleague Matt, it's the same team. Got a chance to work on a really cool use case here with MB cameras and some custom machine learning with a custom machine learning model. Super excited to run through the use case and show it off and get into the meat of the code as well for people who want to check that out. So yeah, very much looking forward to it.
Cool. So yes, folks might not know, right? They know Meraki possibly as, having the switches and the gateways and, the wireless network. And they might not necessarily know about the MV cameras, right? And the whole home automation part of it. So I think this is going to be a good session just to introduce people and show them that Meraki has more than just your typical, networking gear. So tell us a bit, Trevor, how did you get involved in building this? Was it a prototype? What was it? And I hope it's on GitHub, the code and everything, so people can actually have a look at it. Cool.
Yeah, definitely. Sure. Yeah, I can definitely run through it. The team I'm a part of, we do a lot of rapid prototyping with customers, right? So typically we get pulled into these kind of engagements and, get to create a prototype. And in this case, it was really neat because this was very much like an art of the possible kind of use case. So I'll run through a bit of the background here. So for this case, the customer that we were helping and supporting here was a manufacturing customer based out of Brazil. So they were, I think, specifically making cars, if I remember correctly, car manufacturing. And they came to the Cisco team. So they had Meraki investments already. So they had Meraki APs and Meraki MXs already. And they came to the Cisco team and they were saying, hey, we have a unique issue that we're trying to address. And in our line of work with our factories, we have our employees that are wearing personal protective gear, right? So helmets, reflective vests, things that keep workers safe. And one of the challenges they're facing from both a regulation and kind of compliance standpoint is they need to make sure people are wearing proper gear for safety, right? So people are, properly protected when they're working in these environments. So the challenge they were having is that they had this poor compliance officer, and his sole job was to run around and hit people over the head if they were not wearing proper helmets, proper vests. That was his job. He was dedicated to doing that. And the challenge they were facing is that they had a large factory floor. A lot of different areas of the factory, different parts of the factory where specific gear needed to be enforced. And it was really challenging for this individual and people helping him to ensure people were properly compliant, wearing the proper gear. And it typically involved him just roaming the factory, constantly looking for violations with people, right? So they came to the Cisco team and they were like, is there a better way to address this? I mean, so maybe we could do something with cameras. Their executives had started doing a little bit of research. Some of their IT team did some research. And they were saying, hey, we found that it looks like it may be possible to do some kind of image detection. I mean, I think that'd be neat. Could we do something with cameras? And that's where, as a team, we came and said, hey, we have Meraki cameras. They're more than just cameras. They have a lot of these really neat people detection automation capabilities. What if we coupled that with some custom machine learning to detect and see if people are actually wearing proper gear? So at that point, we got pulled in and we got engaged as a team to build a prototype to show that this was possible. And a big goal of this project was to develop a solution and prove that we can successfully detect whether or not proper gear is being worn. And then to be able to demonstrate that in a nice visual way for the executives, because they wanted to run this solution in an executive kind of briefing center where they could show off the solution and be like, hey, it's possible. let's get some buy-in and investment and deploy the solution out across the factory floor. So that was the background and the setup. Again, a really cool use case. I really enjoyed working on it with a colleague of mine. So the two of us were tasked with basically building this prototype and tackling this problem. So yeah, that was the background of the case.
I see. So it's really interesting to see the use cases that people come with for the MV cameras, because I know also the Cisco store here in San Jose, right? They were using MV cameras for people counting. So at this retail point of sale, right? It's like how many people are in the store? Do we need to bring up another cashier from the back to if there's too many people that are not getting served, right? So like what's the waiting time in the queue? So you can build all this nice, automated solutions on top of these cameras that, can help you with detecting people, with detecting protective gear like you're going to show us. So it's really interesting to see how the use cases that people come up with and how far it has evolved and the amount of automation that is possible these days with just, a simple camera mounted somewhere, and you got all these machine learning models running on the camera itself, right? And being able to make these decisions at the edge of the network. So really, really cool stuff.
Yep. Yeah, it's far more than just a camera. That's my favorite thing that the Meraki people say, and it really is true with all those advanced use cases. So yeah, that's cool stuff.
Cool. So tell us a bit how you got started, right? Because did you have any machine learning background, or or you kind of like how did you
question.
get right? Because it's a pretty new technology. So I mean, I know not a lot of people have done this, but I'm curious how you got started into this, and if you have any suggestions for people looking into also using machine learning in their own environments.
Yeah, absolutely. So to answer your question, my experience coming in, I did computer science as my background in school. So that's where I was coming from as a developer. I took one class that had one single module on machine learning, like what it is at a high level. Here are some basic vocabulary, and that was it. So I'd never really built any models, never really used any models. It was on my to-do list as things that I wanted to check out and get better at. So I actually came into this very much not knowing a lot about machine learning. And part of what I'm hoping to do today is show the platform that I used to actually build the model and train the model, and some of the resources I used, because I basically started this whole case and this engagement with, okay, I need to do a crash course in machine learning. And through this platform that I'm going to show in this thing called the YOLO model, which I'll get into more details in the demo, I was able to build the model, collect the images, and actually go through the process of constructing and using this model successfully. So yeah, that's where I was coming in with very little experience, and it was personally very rewarding for me because this was a real use case. It was a real issue the customer was facing, but I could also develop my own skills with machine learning and actually get to practice with a real use case where the customer got a lot of value out of it. So yeah, I'll definitely show those pieces today because I think without that platform, it would have been very difficult to get up to speed as fast as I did on machine learning. So yeah, that's where I was coming from on that side of it.
All right, so we'll see the platform in a bit. Good stuff. So then, folks, any questions? As usual, let us know in the chat. Drop messages in there. I see Ehsan, thanks for joining, Paul. So then, Trevor, let's have a look at the demo, right? Let's see, because I'm curious.
Yeah, absolutely. Let me go ahead and share out my screen, and then yeah, we can check out the demo. I know if you're like me, when you're sitting in these sessions, you want to see it. It sounds cool, but let's actually see it in action. So let's take a look at it, and yeah, we can actually take a look at the code afterwards too, and peel back the curtain. So let me share my screen.
Yeah.
All right.
Here we go.
Cool. All right. Can you see my screen?
Yes. So this is kind of like the architecture, right, of the solution?
Yes. Yes, so I drew up this quick diagram here because I think it'll be important to level set just the architecture, especially as we start getting into the actual code. So at a high level, this solution is composed of 3 different pieces. And the basic workflow, the basic process workflow was we wanted to detect people on a camera. So, somebody like a worker walks in front of the camera, take a snapshot, run our custom machine learning model to see what kind of gear they're wearing, if they're wearing the proper gear. And then if there's a violation, this customer is a Microsoft Teams user, so they wanted to send a adaptive card saying, hey, here's a snapshot. This is where the camera serial, this is where the camera is. And here's a violation for the compliance officer to monitor in that space. So that was the general workflow. The solution itself is composed of 3 individual microservices. Everything's Dockerized. So we've got individual Docker containers, 3 Docker containers all working together to build this solution. At the top here, we see it all starts, like I was saying, with the Meraki camera, listening for what's called MQTT messages. So this is how we can tell when a person has been detected, and one of the benefits of the Meraki camera. We get a snapshot. We then run our custom machine learning. So I've abstracted it a bit here, but don't worry, we'll get into the details of what's actually happening here. So we actually run that analysis. Then we determine if there's been a violation. So if there's been a violation, like I was saying before, we're going to send a adaptive card with that snapshot included to Microsoft Teams. The 2 other components here, so I'll get into this. This was actually one of the gotchas as I was going through developing this. For Microsoft Teams, the image needs to be, if you want to include a snapshot in a message, publicly reachable and publicly hosted. So typically people will use like cloud resources like S3 buckets. In this case, the customer didn't have like an Amazon or cloud investment, so they wanted to keep everything as limited to the dependencies as much as possible. So I have a separate app where its entire purpose is just to serve up images to these Microsoft Teams. So we see sending the annotated image, serving up the image at a publicly reachable place using ngrok in this case for my local development environment. And then we also have this visualization dashboard. So before I was mentioning a big part of this was getting executive buy-in. So we wanted to show this off at an EBC kind of center where we could show off this technology for executives. So there's also a visualization dashboard where you can visually see the live stream of the camera as well as annotated images. So there's a bit of an exchange here with saving the annotated snapshots to a folder, reading those in, as well as sending what I call PPE state, which you'll see when we look at the dashboard is just a really simple circle that either is like red if there's a violation, green if there's everything's good, or white if it's unable to determine it, the PPE state. So those are kind of the 3 pieces. Hopefully that's all clear. I don't know, Adrian, if that all makes sense to you, but this is a high level diagram of what's happening.
Yeah, so built in by default, right on Meraki cameras, you have the people count, people detection is there kind of by default. So you take that image whenever a person is detected, right? You take a snapshot and then you feed that image through your machine learning to actually detect if the person is wearing a PPE protective gear or not, right? So we kind of
yes, absolutely.
adding an extra layer on top of just the person detection that comes built in with the Meraki MV cameras.
Yes, absolutely. And
right.
that's a really good call out because that's one of the nice value adds of the Meraki camera is that we can just leverage that built-in people detection and we're just adding an extra layer on top, as you're saying. So, yep.
Right. Okay. Cool.
All right. So let's go ahead and check out the demo. A few things before we do that. So everything is available on our GitHub, our team's GitHub here. So everything I'm going to show, coding wise, demo wise, is available on our GitHub. If you just go to GVE-SW and search for Meraki NV custom PPE detection, this is where you'll find all of the code that we're going to be showing today. And then I'm going to also run through a few of the prerequisite pieces before we actually demo it. So in terms of camera, I have a Meraki camera here. If you look at the Meraki dashboard, this is my office camera. It's actually, there you go. Hello. You see me there. It's up on my wall. So if you want to pause the video at this point, if you're watching the playback and judge my office setup, feel free. That is me. That is me right there. So this is the camera we're going to be working with. I have, if you're not familiar with Meraki NV automation, there's an NV Sense that needs to be enabled. So I have that enabled on the camera. I also have RTSP enabled too. So just showing off a few things here. So I have the NV Sense, which is a separate API that needs to be enabled on the camera. And then I also have some other pieces like the MQTT broker, which I'll come back to set up here. But that's the camera we're going to be working with today. I also have a Microsoft Teams instance here. So these are some old messages I was testing a bit earlier. But I have a Microsoft Teams tenant here, and I have this team space here. So this NV PPE violation dash detection space. And this is where the adaptive cards will be placed into this space. All right. So let's go ahead and run the solution. I'll start up the Docker containers. So give this thing a second to start. And then I will start up a dashboard as well.
And Trevor, can you share with us the GitHub link for the repo?
Yes, absolutely. I don't know what the best way to do that is, but I can.
You can drop it in the private chat option, and I'll share with the folks.
Let me do that. All right, there you are.
Cool. Thank you.
Okay, so let's go ahead and go to our dashboard here. This is that visualization dashboard. So I'll get into how these drop downs and everything are populated, but basically you populate the cameras that you want this solution to be monitoring. So it does support multiple cameras. I have the one here. So let's go ahead and tune in. And then if we give this a second. Okay, so pretty simple visualization dashboard here, but we see on the left side is the RTSP stream. So you can see me hopefully waving here. Yep, so that's the live footage. And then we have on the right-hand side here the most recent image. So let me actually stand up. It's having a hard time detecting. Okay, so I'm not wearing anything right now. And then we'll give this a second. And essentially what it's doing is every 20 seconds, it's taking a snapshot and then it's running the image analysis on the snapshot. So it's currently waiting. So 1 second. And then now that I've stood up, it should have an easier time detecting that I'm not wearing anything. All right, there we go. So I have it currently checking for vests and helmets right now. So we can see the violation detected. We can also see this is that state I was talking about. So it's currently invalid because I'm not wearing the proper PPE gear. So if we actually take some gear, which if you can see here, bought this at Home Depot. So I actually went out and bought some gear so I can at least look the part if I'm ever doing construction work, although the work will be a bit shoddy. Let me put this helmet on. It'll be a little tough to balance it on my headphones. And then let me put this vest
and you get your vest.
Yep.
Okay.
Yep, real official. All right. Let me, all right, it caught me while I was putting it on. Okay. But yes, so you can see, I unsuccessfully put this vest on there, but you can see that it detected I am wearing the 2 pieces of PPE gear that I'm enforcing here. And I was able to change the state to valid. So pretty neat. It's a cool little visualization dashboard, and was a way again to show the executives that, hey, this is actually working and this is a viable solution.
Very cool. Oh, Trevor, did we lose you for a bit? We're back.
Oh, we are. Okay. Sorry. I don't know where it cut out, but hopefully you saw the dashboard. But can you hear me? You can still hear me now, right?
Yes. Hear you and see you. Yes. It was,
okay. Sorry about
it was
that.
a glitch. It's okay.
Yes. All right. So if we check, we see a couple messages came in here. Let's take a look. This was the initial one. So we see this is what a adaptive card message would look like. really simple. It includes the camera serial, what I call a PPE zone, which I'll get into that, a location. So they organized by floor, and then also alphabetical section of their factory. So this would be an example of floor 1, section P. And then we actually see the image. So this was the gotcha that I was referring to before. Getting it to actually display here. And again, this was a pretty important piece of it, in my opinion. So we see the snapshot here, and then the compliance officer would see this and be able to determine if there's actually a violation based on what the model displayed here, and then be able to send a message to the person or go down to that section to go reprimand the person. So yeah, that is the solution in a nutshell.
I see. So you were mentioning the 20-second delay or processing time. So you have a video feed, a live video feed, right, going on RTSP stream. So where does the 20-second come into the picture? Does the person have 20 seconds to kind of like just disappear and is going to be missed by the software, or?
So so to be honest, the 20 seconds is put in there so it doesn't cook the the CPU of my MacBook, which is what this is running on.
I
what
see.
I found as I was working through this is that the 20 seconds is to in between like taking a snapshot and running the analysis. So with higher end hardware, you could definitely limit that down and not make it wait. But I found just 20 seconds was where I could arbitrarily put in that sleep so that it doesn't overwhelm my computer, just because it can be a bit computationally intensive. But so that is definitely an adjustable parameter within the code, and with dedicated higher end hardware, you could definitely limit that down as well.
All right. So actually, if you have a NVIDIA dedicated GPU, right, then you could lower that to like a second or even less.
Yes, absolutely. Yeah, it was just so my poor MacBook doesn't melt as I was running this. The poor work MacBook. Yeah, but cool.
All right.
Yeah, if you want to take a look at the code now, we can peel back the curtain a bit and take a look at the magic, if that sounds good to you.
Yeah. And there was a question that came through from Fatane. So he's deeply interested in applying machine learning to Cisco platforms. And then could you kindly share any valuable resources pertinent to this? So Fatane, this video is, exactly that, machine learning applied to Cisco Meraki. Additionally, I'm eager to know if there are any open source projects in this domain where we can contribute. So, I mean, you can, and Trevor, can people actually contribute to your solution here? Do you accept pull requests? Can they raise issues? You do? Okay.
Yeah, so everything we do with this particular project, so I'm showing the GitHub again, everything we do, barring the customer's okay with it, is published out to our public GitHub and is open source. So I would encourage that, feel free to pull this down, deploy this in your own environment, add to it, mess with it. In terms of the machine learning model, so within the repo itself, I don't have the raw image data set. So if you're new to machine learning, there's the raw data image set, which is the actual images that we're training the model on. And then there's the output, which is like a special file, essentially. So within this repo, I have the special file. So the model's already built. So the raw data is not here, but the raw data I also published publicly out here as well. So this was that platform I was going to get into a bit more, RoboFlow. And this is where, if you're curious, even with our solution we're showing today, this is where you can see, here's the 5,200 images that I actually have here. And this is also open source. So feel free to contribute to this, modify it. Again, I'm sure if you have machine learning experience and you're like, oh, why did Trevor make those decisions? There's better ways to do it. Please have at it. Improve the model, work with the model. So yeah, feel free to at least use this as a starting point for looking for examples with this sort of thing.
So cool. So then another question that comes to my mind is, can you actually, so you detect, right, the helmet, the vest, can you improve the model, and especially in an enterprise, right, where the people that are supposed, can you do face recognition and also know who the person that, was infringing on the rules is?
Yes. So facial recognition is interesting. So there's a number of different ways you can approach this. The choices here were to have a local model, again, because this was just a proof of concept,
Yeah.
excuse me, and we were trying to avoid adding in dependencies with like AWS or other cloud resources. But AWS actually has face recognition and models that you can use for PPE detection as well through the cloud. Of course, you got to pay for them, but they have those offerings as well. So I've seen solutions built that leverage that. So you could use like AWS's facial recognition service that they have, upload pictures of people's faces. Of course, you got to get, when it comes to facial recognition, as you can probably imagine, that can be a bit tricky. So you need to get like consent from people and everything if you want to upload your employees. But you could do that and then add that element in as well. So yeah, it's definitely possible to do that. For this particular use case, we opted not to do that just because it was a proof of concept, and I don't think they wanted me taking pictures of all their employees and trying to add that in. But yeah, that is definitely something that's possible. And then you could essentially also have maybe a database and tie that back to their Microsoft Teams, user or something, and be like, hey, that's Trevor. Send a direct message to them, or their WebEx user, whatever platform you're using.
Right. Yes, because that's especially in this setup that you've built where it's all confined and can be on premises, right? If I'm a customer and I deploy this, then I can definitely see having this taken an extra step, adding that facial recognition piece to it, because it's all contained, it's all on-prem. I have agreement from the employees, right, through the employment contracts or whatnot. So all right, so that would mean just enhancing this model or adding a second model for facial recognition. Like, how do you think you would be able to do it?
So the easiest way would be to probably have a second model just to keep things separate. Just because when you're talking about machine learning models, again, if you're watching this, you're brand new to this, you have a concept of classes in machine learning models. So you can see the classes over here on the right. So you're defining, okay, this is going to be no glasses, no helmet, no vest. This is going to be, glasses, helmet, vest. You would probably have to define a class per person. And again, take different images, of people's faces, and then be able to
different angles and everything.
Right. Exactly. Yeah. So yeah, machine learning and training models is very interesting. I mean, I liken it to essentially like training a child, right? You're like, okay, I need to teach this child, like, this is what Trevor looks like, right? This is his face. This is what a vest looks like. This is what a helmet looks like. And then more importantly than that, to train it on, this is what Trevor doesn't look like, right? So here are other people, so you can start to distinguish, right? So yeah, I would probably have it be a separate model, but you could definitely add it to here. I just would think that if you combine them all, it could get a bit messy. But yeah, so you get a couple different options, or you could leverage some of the pre-built solutions out there through like our partners or AWS. So yeah, a bunch of different options for how you could do it.
Gotcha. All right, cool. So let's have a look at the code. Let's see. So you have 3 Docker containers, right?
Yes.
You have your front end, you have your PPE, like where your model is running, and then you have that image processing container that just takes images and sends them to Microsoft Teams.
Yes, that is correct. So yeah, I'll run through the individual components here now. Let me clean this up a bit. Okay. Can you see my screen? Can see the code?
Yes.
Okay,
And can you
awesome.
zoom in a bit, please? Just make it a bit the text larger if you can.
Yes. Let me see. I think it's. How do I do that?
Command plus? Is it Command plus?
You know what? I figured you might ask something like this. So hold on. I had it pre-pulled up, so I was trying to predict. Okay, Control Shift. That's what it is. Okay, Control Shift dot. I'm not sure. I might not do it for the README. That might be. Okay. Yeah. So I'm not sure if it does it for the README, but okay. Hopefully you can see the text, but I won't spend too much time here. Just wanted to highlight a few different pieces as we're going through the code. But yeah, so for the solution, as you were saying, there's the 3 individual containers. A couple just high level things. So the model that's being used here is called the YOLO V8 model. So that is a whole topic in and of itself. When you're talking about machine learning, there's different models that you can use as the basis of like your framework, that are using different algorithms under the hood. So this is using YOLO, which is you only look once. So it's not you only live once, you only look once. And this is version 8. That is what the model is built on. There's 3 supported pieces of PPE: the safety vests, safety helmets, and goggles. So I had goggles turned off just because I was facing away from the camera for that demo I was just showing. So we were just using vests and helmets, but those are the 3 that are supported. There's 3 different states. So we saw on that visualization dashboard, there's valid, which was green. So that's a full kit has been detected. And I'll discuss how that's defined within the code. There's invalid, which is 1 or more pieces are missing. And then that's where we send our Microsoft Teams message. And then unknown. So if we're unable to detect all pieces of the kit, we have an unknown state. So it does still, in this sense, and we saw with that Microsoft Teams space, still require that compliance officer, to validate, just because the model's not perfect. But those are the 3 states that we're using here. And then I already clicked the link here to show like the raw data set, but the raw image data set is publicly available. I just have some graphs here. So, I thought this was just very visually appealing and pretty, but the most important thing to look at when you're looking at all this data, when you're evaluating models, is its precision and its accuracy, which is represented here. So the model was able to, after the training, get around 85% accuracy. So that was what we were able to get. Of course, if you want to take the model and improve it, please, I would encourage that. That's definitely, if I had some more time working on this project, I would have spent much more time just trying to master the machine learning model and improve it. But that was the final results of the model in terms of accuracy.
So how would you improve the model? Would you just add more images to it because you have 5,000 something? Is that one way?
Yes. So the interesting thing with machine learning models is that, again, I'll keep likening it to training a child. So the more images you have is one way. The more images you have, the better. But it also involves having images from like different angles, different lighting, different perspectives. So the diversity of images is also really important. So like different people, and it sounds silly to say this, but like different races of people, like, men, women, taller people, shorter people, like all those sorts of things start to really matter. And in the case of even the gear itself, like different helmets, right? Like yellow helmets, white helmets, pink helmets, different colored vests, all that, those sorts of things contribute to just making like a more diverse and verbose data set. And then from there, that will improve the model just because it has seen more variations of what you're trying to detect.
Gotcha.
Yeah, and the cool thing with that RoboFlow platform too is that it actually automates a decent amount of the creation and variations of images, like rotating images, adjusting saturation of images automatically just to expand your data set. So you don't have to be responsible for collecting like 20,000 images, because that can be the most time consuming piece of building a machine learning model, is just getting the raw images and actually manually going in and drawing the boxes and saying like, oh, this person has no glasses and a helmet on. Like that can be the most time consuming piece. But again, it's really important for model accuracy.
All right. Cool. Yeah, that's what I was thinking too. So makes sense.
But all right. So before getting to the code, the only other pieces that are worth calling out. So obviously Meraki API key connection to Meraki. I mentioned MQTT. So if you're watching this, you're not super familiar. MQTT is just a pub sub, publisher subscriber style model for receiving messages from the camera. So it does require you to enable that, and then also enable the special MV Sense API on that camera, and then be able to listen for those messages using what's called an MQTT broker. So I'll show that configuration. There's also the Microsoft Teams. So you can use like your personal Teams instance, or there's developer instances. So I was using like a developer instance that I could get for free. And then I also used NGROK in this particular example, because for serving up those images, as I was saying before, they needed to be publicly reachable images. So, the proper way would be to use something like S3, or, a cloud resource, a cloud bucket resource that actually has
Trevor? Still there? Disconnected a bit again. I hope, folks, you can hear me. Let's see.
Hey, hopefully I'm still there. Can you hear me?
You're back, yes.
Okay, I switched to a different Wi-Fi. I apologize for that, folks. I'm not sure what's going.
And you disconnected again, Trevor. So this is how you know that it's live. Oh, you can hear him, Glenn? Oh, then is it a problem on my side? Let me quickly do troubleshooting here. Looks like it works for me. So while we wait for Trevor to get back, oh, there we go. He's gonna join back again. So that's how you know that this is real and it's live, right? In instances like this, situations like this, when things happen, internet is not perfect. So let's see once Trevor comes back. But yes, I had shared the link for this. We can hear you. Yes, Trevor dropped if Trevor dropped. If you could hear. Okay, so you can hear me. So I had shared the link. We have put it there for the repo, right? If you want to do exactly what Trevor was showing, the exact demo with protective gear detection, feel free to clone that repo, build on top of the code, modify it to your own environments. What else? Building the model we've seen with the images, right? And he was using a platform for that. So there's all types of platforms that are helping you to build these models, so you don't have to do it yourself. And Trevor is back. Let's see.
Okay, I think I'm back. I'm not sure what happened there. Can you hear me?
Yes, we can hear you.
Sorry. Of course, it decides to cut out right while I'm getting to the good stuff. I'm sorry about that, folks. I'm not really sure what happened there, but hopefully it's stable now. Okay, let me get back to sharing my screen. Yeah, sorry about that. Of course, got to have some fun technical difficulties as we're going through,
It happens. We're doing well on time anyway, so I think that's what happened, right? Because
yeah, it was like you were doing too well. Okay,
yeah.
All right. Hopefully it's stable now. Hopefully you can see my screen.
Yeah.
Let me pick off. Okay, let me pick back up where we were at. Okay. All right, cool. So now we're where was I? Okay, we're going through the prerequisites. Okay, that's really it in terms of prerequisites. Like there's a couple configuration files that are worth calling out. And I'll share those now, and then we can get to the good stuff, the code. So within this code, okay. Sorry, am I still there?
Yeah, it was just a blip this time.
Okay, strange. Yeah, I'm on my apartment Wi-Fi too, so I'm not sure. Maybe they're cutting off our service or something. Okay, but anyways, there's two main JSON files that are important for configuration. There's the camera file, and then there is the zone file. So when we look at the cameras file, this is how I actually provide a list of all the different cameras we want to include in our solution. So this solution does support multiple cameras. There is like multi-threading that's happening, so we can simultaneously listen to multiple cameras and run the analysis on multiple cameras. Again, that can obviously grow, as you imagine, exponentially in terms of like computation resources. So the better the hardware, the better the performance will be as you scale the multiple cameras, but it does support it. And you just provide like the serial of the camera, a zone, which I'll define what that is, and then some additional parameters. So this location field, that was just something I arbitrarily added in because the customer was asking for additional details on those adaptive cards. If you remember, like 1P, like where is this camera? So if you're taking this code and want to expand it out, you can very easily add other fields and just include those fields in like metadata, essentially, in those adaptive cards. And then it also does support zones within Meraki. So if you're familiar with Meraki NV cameras, you can define zones that are within the full frame and that you can use as the thing that you want to consider within that frame. So if we define a zone, for some of their cameras, they had only like a walkway, but they had a window behind where you could see people. So if we only wanted to detect people within that walkway area on frame, you can define a zone to do that and also listen for those zones. So that's supported within the solution too. When we come to PPE zones, so this is how this is, again, data structures that I just came up with. PPE zones are how we define which pieces of PPE gear we want to enforce. So one of the other requirements for this customer is that they wanted the flexibility to be able to only enforce, as I was saying near the beginning, like specific pieces of PPE gear. So not all places in the factory need helmets. Not all places need vests, glasses. Glasses was the big one, actually. Most places needed helmets and vests, but glasses weren't always required in every part of the factory. So you can go through and define a zone, call it whatever you want. So I have the default all zone here. You can call it whatever the zone, whatever you want, and then define true, false for which pieces of kit that you want to actually enforce. Besides that, there's a couple environment variables, just providing like the Meraki API key and some of those pieces there. From the prerequisite. But besides that, those are the initial pieces that you need for the solution. So if we actually get to the code, there's the three separate pieces like we were showing in that diagram. This PPE detection is the main piece. So I'll focus on this because the other two are pretty straightforward Flask applications, again, just serving those images and then also just serving up that visualization dashboard. But this is where the bulk of the magic, so to speak, is happening. Basically, within this code, there's a few pieces to call out. So if you're brand new watching this to MQTT, like I was saying before, it's a pub sub model. Python has a number of libraries that you can use to interact with MQTT. So one of the real popular ones is PAHO or PAHO. I'm not sure how to say it, client. This is one way you'll find frequently if you're looking for examples of MQTT with Meraki, how you can actually listen to those MQTT messages. So the way that you actually initially set up the listening to those messages is you create like an MQTT client. You define two separate methods, an on connect, which is exactly what it sounds like. So once I connect to my MQTT server, which is essentially like a server in the middle where Meraki is like publishing from the camera, messages that it detected people to that server. And then we're listening to that server and saying, hey, if you have any messages, that have been published by those cameras, let me know. So what to do on the initial connection and then what to do when you actually receive a message from the MQTT server. So those are the two things to define. Then you define a connection, or you say connect. This is just, hey, we're ready, go ahead and initiate the connection, and then loop forever. So we just have this thing running forever. If we take a look at our on connect, it's a pretty simple method, but this is where we go through and we start to define the topic we want to listen to. So when you're talking about MQTT, there's the concept of topics, and that's how topics are how you are able to organize the actual like messages that you want to get. So the MQTT, each camera has their own topic. They're publishing messages to that topic, and you're subscribing to that topic, which means you're going to get the messages that are pushed to that topic. So each camera, so we iterate through our list of cameras, where the cameras is just loaded in from this JSON file. So it's just simple JSON loads, loading in the actual data structure into our script here. And then we iterate through every camera and say, okay, if there's a camera zone defined, there's a slightly different topic you need to listen to. But otherwise, you want to listen to the 0 topic, which is a full frame topic. And if you're wondering where these topics come from, if you look back on the Meraki dashboard near the bottom, you'll see the MQTT topics that are available. So if you're wondering how did I come up with this, where did this come from? when you enable MV Sense on the cameras, you'll see these topics and exactly like what they return, what kind of messages they return. So again, we're listening to the, this was actually a gotcha. You would think it should be raw detections, but for some reason that one didn't work all the time for me, but 0 seems to work as one that I saw as an additional option. So that's why the 0 one is not here, but this is where those topics come from. So once we actually subscribe to each of the individual topics, then we're ready to listen for messages. So that's where we get into the meat of our code in this on message. There's a few pieces here to call out. This is where the actual model detection is going to be happening. So we first get the payload of the message, and that payload is typically going to look like, let me pull open the Docker logs here so you can see. Okay, so if you see this line here that I'm highlighting, that's what the payload looks like. So it's a really simple payload, a timestamp, and then the amount of people that are detected. So when you're doing, in general, people detection automation with NV, typically this is the kind of message you're working with. And it's, again, a really convenient way to detect that someone's there in frame, so you don't have to constantly, pull the camera for snapshots over and over and over again. This is like a way that we can be more reactive and only react when a person is detected, which is pretty neat. So we detect that a person is there. That's what that payload looks like. We load that guy in. And then from there, we spin up a different thread. So I was mentioning before, for scalability with multiple cameras, and also most importantly, not to stop and block the MQTT main thread. We want it to constantly be running and listening for new messages. In order to not block that while we wait for the machine learning model to actually run the detection on the image, I spin it off into a different thread. So I start up a different thread that's actually going to do the bulk of the heavy lifting with image detection and the analysis. We start going through and we start up that thread. So I call it process message. That's where the bulk of the work is being done. Within process messaging, this is where I start to do a few different sanity checks. So I want to make sure that the serial number that we're receiving the message for is actually one that we have defined in cameras, one that we actually have a zone for. So again, some sanity error checking there. And then from there, this is where we start to run through the main processing logic. So the first is generating a snapshot. This one is pretty straightforward, just an API call. So there's a REST API call through the Meraki API to generate a snapshot at the current timestamp. I generate that snapshot. It comes back in URL format. So if we look at, again, the Docker logs, the snapshot itself is a URL, like a special Meraki URL. So we have to actually download the image if we want to, download it as a JPEG so we can actually operate on it. So it comes in as a URL. So we generate our snapshot. We then, let me go back. So there's a decent amount of code here. Okay, so we generate our snapshot. Then I have a download file method as well. The way I did a naming convention for the snapshots is just a serial number _ snapshots. And if you look at the code, when you're running it, a snapshots directory will be created. And this is where all of those individual snapshots per camera are going to be living. And each time a new one comes in, it just overwrites it. Again, you can filter by serial number just to keep it nice and tidy. And you'll see the snapshot as well as the result of the machine learning model, which is this annotated snapshot. So in this case, I wasn't able to detect anything, but that would be where the bounding boxes are drawn on that actual snapshot. So the download method, again, pretty standard, just attempts to use that URL and attempts to download it. Meraki can have a bit of a delay for when the image is actually available to be downloaded from that URL. So it may require a couple different attempts, which is why we have this while loop. But nothing ever got close to 50. Again, 50 was just an arbitrary number I chose there. But if there's some kind of problem, there's error handling, error checking too, which will stop that thread if there's some kind of problem with getting the image or the annotation. But it essentially just attempts to go through, attempts to download it, and then once successful, saves it into the snapshots folder here. Once we actually have our snapshot, then we can go into the actual image detection and the actual analysis on the image, which is the good part that I'm sure people are actually interested in seeing. So we have our snapshot. Yes. Then we go to this detect PPE on image. So this is where we're actually going to be running the prediction. So I mentioned I use a YOLO V8 model. One of the really nice things about the YOLO V8 model is that it has an SDK up at the top here. So it's called Ultra Analytics, which is, I believe, the company who's now responsible for the YOLO V8 model. And it has this SDK called YOLO, which is really nice. So this is where, again, I was mentioning I came in with very little machine learning knowledge. From reading the documentation, it can be as simple as running predict, like .predict on the image, which is pretty amazing. Yeah. So like it's again, it used to be, from what I read, used to be extremely complex. And you'll see in the code, there's some other processing I do, but the crux of it is that, and it abstracts away a lot of it from you, which is really, really nice. One thing that's worth calling out is up at the top here, you do have to define your YOLO model. And so it's class-based. So you define like a YOLO class. You provided a path to the special .pt file. So I mentioned before that the raw image data set is available on that RoboFlow platform where it's being stored, but the file itself, it's a special .pt file, which I'm not entirely sure the contents of it, but it contains essentially the results of the training of the model. So then you provide that in and you say, that's the model that I want to use. And again, if you're curious where that is within the directory, it's under the PPE data set here, folder here, and then you can see weights. And this is where the actual results of the model are located here.
Mm-hmm.
You can also define a confidence threshold too. So when it comes to detections, you define like a minimum floor confidence threshold. So only if you're at least 50% sure about a class, include that. And this is just a way to just filter out the junk. But all right. So if we get back to the actual analysis, we then call this .predict. We give it the snapshot path and we provide the confidence. So again, it's pretty amazing. So if you really just want to get started with it, that's essentially what you do. It's pretty remarkable, right? So they've done a really nice job of abstracting away a lot of the complexity. A lot of this additional code you'll see here, I won't belabor it too much. So we're good on time, but involves a lot of just additional kind of processing that I do. So it returns a list of results because there could be multiple results. Each result represents a run on the actual image. So attempting to find like which classes are present, where the boxes are, all that is represented in a result class. From there, I start to break apart the results class, and there's a few different pieces within each result. The first is these boxes. So a box is exactly what it sounds like. So those boxes we saw on the annotated, images, right? Each of those are represented as a class here. And each of those boxes contains certain attributes like the class ID, class names. So those IDs and names, if you remember when we were looking at the RoboFlow platform, are the ones I defined, like no helmet, vest, no vest. So then, yeah, those pieces are there. There's some sanity checking here. So if the class is a person, then just ignore those because that would just clutter up the images. Also check if the PPE that we're trying to compare, if it's within the required PPE. So I load in the required PPE, which again is just loading in these PPE zones that we defined here. So which PPE do we actually care about? Load those in. Check and make sure that it's actually part of the required PPE. If not, then just skip it. There's some probability calculations as well. So this is that confidence percentage. So if you remember on the annotated image, like 70%, that also gets calculated here. And I just do a little rounding and extract it from that box class. There's also some coordinates as well. So I actually end up drawing the boxes myself. So the interesting thing with this platform is that it returns the box coordinates. So it returns like the X, Y of the center of the box, and then the width and the height of the box. So you actually need to do a little bit of math. So hopefully that doesn't scare anybody. A little bit of math, a little bit of calculation to be like, let's figure out what are the 4 coordinates of the box so I can actually draw the box on the image is what's happening here. So I get the center coordinates, I get the width and the height of the box. I then, once I have those all calculated, I keep track of all the different outputs and all the different classes. And the reason I do that is because once I've analyzed all the results that come back, I want to then, like I was saying, draw the boxes. So figure out like the top left coordinate, the bottom right coordinate, and then those are the 2 you need to draw a successful box around, whatever you're trying to detect. And then I have a little bit of additional logic here where if no is in the class, draw a red box, again, purely visual. If no is not present, then draw a green box. And then finally write those to the actual image. So that's what's happening under the hood. But again, the actual prediction is handled by this method here. All of this is just me custom drawing the boxes and adding the label, up at the top and all that, just again for visualization purposes. But yeah, that's so it's pretty remarkable that the prediction is happening at just with that method, and then the rest of this is just drawing the boxes and creating labels. The actual logic that is worth calling out is once we've actually analyzed the results that come back, we have this detect PPE state method, and this is where I'm actually detecting, okay, do we have all the right PPE or do we not? Is something missing, right? So this is where that actual check is. This method is pretty simple. It's a simple check of, okay, for every class that we've detected in those results, let's go ahead and see if they're in the required items and if their value set to true, right? So if we have any no class that's present, where no is part of the text, then that means that there's a PPE kit piece that's missing. And if it's one of the required ones with the value set to true, then that's a problem, right? So we need to return false. If not, and everything is present, then we're going to return true. And then again, if there's some kind of issue, like we're not able to detect, we're going to return none. Based on the results of this method and the state here, we then check, okay, if the PPE state is false, which means that there was a violation detected, which we returned false in that previous method, that's when we need to actually send the annotated snapshot to that Microsoft Teams app. If you remember, that was one of the connections. So we send it to the Microsoft Teams serving app so it can host it. And then we finally send that Microsoft Teams message here. And this one is using an adaptive card. So there's a standard adaptive card here. If you've ever used any of the WebEx cards, it's very similar. So very similar structure. I just have a basic card here. So you can customize this, to whatever you want it to look like. This is just the default card I include with the repo if you, don't want to come up with your own card. So that card is loaded in. We then start adding in the different pieces here, like the timestamp. So let's get the current timestamp, that we're going to include in this adaptive card. The serial number of the camera, a camera location, the PPE zone name, as well as the actual URL here, which again is a special URL that's based on that serving app that I had defined as like one of the 3 services. So it can be actually reachable, and we can actually have that snapshot included. And then from there, we actually send it to the Microsoft Teams space. So if you're new to automating with Microsoft Teams, they have these really nice webhooks that you can attach to a Microsoft Teams space. And all you have to do is make a post request to that webhook. And as long as it's in the appropriate format with an adaptive card, it ends up just sending it right to the space, and then it renders the adaptive card. So this was a bit of a gotcha. It took me a bit to get the formatting right, because if the adaptive card JSON is wrong or not in the right format, things will not successfully post and it'll have some issues. So there was a bit of a gotcha here and a bit of a struggle to get that piece working, but yeah, now we were able to get it working with the adaptive card. So that's how it makes its way over to Microsoft Teams. I know we're a little tight on time. So the other 2 apps are, pretty standard Flask apps. If you're, again, feel free to look at the repo. The visualization one just renders that dashboard with the different streams that you can see in the annotated images. And then the other one is just serving up the Microsoft Teams images as well. But yeah, this part here, the PPE detection, is really the meat of it. So again, I know I went through fairly fast, but hopefully this all makes sense. I don't know if there's any questions or anything. I'm more than happy to take a quick stab at it. But yeah, I don't know, Adrian, if you have any questions or not, but that is the crux of the solution here.
Yeah, I mean, my mind is blown, right? Having just that SDK with the dot predict. Yeah, I mean, that makes it so easy. So then building the model on that platform, I think that was the last thing that we wanted to cover, Trevor, right?
Yeah, so I do want to take a couple minutes. Sorry, I know, again, we're right up on time, but with that platform. So if you're brand new to machine learning like I was, I would highly recommend checking out these YOLO models. And they have this RoboFlow platform. So again, this is the data set here, but it's really cool with this platform because they've essentially GUIfied, provided a GUI for you to build these models. So if you take a look at the image data set here, you can actually take a look at the images, and then you can actually drop your own images in, and then they provide the ability to, if we take a look at this random image here, define a class and then draw a box around it. And yeah, all these sorts of things are provided through this platform, and it made it much easier to build a custom model for me, because from what I read previously, actually doing this and annotating and building this could be a real pain and be really difficult. So yeah, I would highly recommend checking out this platform. Their documentation is fantastic. This is their blog, so I was using this guy. He shows up all over their YouTube and everything for a lot of the documentation they do. But they have really nice documentation, fantastic YouTube videos. The actual, again, documentation is really, it gives you real examples for how to do it in Python, which is awesome, and how to actually train the models and everything. So it's quite verbose with what they provide. So if you're brand new to machine learning, I'd highly recommend checking out YOLO V8, this platform, mess around with building the actual models and doing the annotations. And before you know it, you'll be building your own custom models. So that was how the model is actually built. But again, this is all open source and all available. So feel free to check out this model. If you want to improve it, make changes to it, I'd highly encourage it. But yeah.
So the output of this, right, from RoboFlow would be that RT file.
Yes, yeah. So you can
that you load up, and that's where all the magic actually is, the result of the model.
Yeah, so you can actually see. So it gives you a couple. I think it's up to 5 that you can train within the cloud, and then you can see once it's trained, it'll give you the check mark, and then it'll actually provide a bunch of different formats. So there's previous versions of YOLO, TensorFlow if you're using that as your model, your base model. But YOLO V8 is the one that I used, and clicking this will download all of those files that you saw. And one of the other cool things to call out really quickly here is that you can see that it started with 5,000 images, but this platform also lets you define any kind of pre-processing or augmentation steps too. So if you remember, I was talking about you want to be able to train with brightness and adding what's called noise, like fuzziness to images, all that kind of variations to images to try to make the model more robust. You can also do it here. And that's why if you actually look at the real thing, it has around 11,000 images. But thankfully, I did not have to get 11,000 images, because that would have taken several months probably for this customer in this use case. So this significantly sped up the development and the time to value for the solution.
Cool, so cool. All right, so wrapping up the session for today, Trevor, thank you so much. Apologies, folks, for a couple of glitches here, but we made it to the end. So thank you so much, Trevor. This was really informative. It's much more clear now, in my mind, or at least. So RoboFlow, right? YOLO models, have a look at that. There's an SDK with YOLO for Python that makes it so easy for you just to do a dot predict. There's a method, right? So it's very nice and easy in a way, right? Just all the heavy lifting is done for you, basically.
Yeah, absolutely. Documentation is really solid too. So yeah, feel free again to check out the platform, check out the GitHub link that we have there too for how to actually tie it in with NV cameras, so you can then start running predictions on real cameras. And yeah, hopefully you'll find, like I did, that it's quite addicting. It's really fun once you really get into it and you get over that initial learning curve. It's quite fun. The possibilities are endless.
All right, and then we shared the GitHub link with you folks. If you want to follow exactly what Trevor was showing, right, all the code is in there. If you want to contribute, pull requests, right, issues, let Trevor and the team know. And thank you all for joining. We ran a bit over. We appreciate you being here today. And for me, I'll see you next year. We'll take some time off, going to Cisco and Melbourne next week, and then we'll pause a bit the live streams until January next year. So I just wanted to say, happy holidays to everyone. And thank you for all the support this year, and hope to see you on live streams again, and all these discussions, everything involving the community next year also. So be on the lookout for our first guest, which will be next year. I'll send, as usual, a LinkedIn message and all of that. So thanks, Michael. Thanks, everyone. Fatane, all the questions coming, Glenn, everyone, Paul. And most of all, thank you, Trevor, for showcasing your super cool use case here. So
Yeah.
thanks,
Yeah.
everyone.
Thanks for having me. Yep.
Yeah,
Thanks,
my
everyone. Good to
pleasure.
see you.